role of the Manufacturing Technology Centre is to develop manufacturing processes for the future. So for all kinds of companies, for Rolls-Royce, Airbus, a whole raft of other companies.
Laser welding's been used for a long time in the steel industry. It's also been used for a long time in the automotive industry, not just for welding but for brazing as well. It's now starting to become more prevalent in aerospace.
There's a lot of development been going off in lasers, particularly the introduction of fibre lasers. We had a number of our member companies were keen to look at laser technology, particularly for welding.
My job is to develop laser processes such as laser welding, laser cutting, laser cladding, and prove that the processes are viable to industry.
Tec built the entire system, right through from the design. We included everything, so this is right from the lasers, the robotics, the manipulation, and most importantly to contain all that, a safety system around that. The big cabinet at the back with the 2 orange lights on the top is the laser power source. This generates 20 kilowatts of laser power, and that fibre optic feeds it through an opening at the back corner of the cell into the main cell.
So we have a 3.5 metre reach ABB robot which holds a Precitech YW52 welding head. The laser energy is transmitted through the fibre optic cable. We could weld single pass carbon manganese steel up to 20mm thick, and that's at a welding speed of 1 to 2 metres a minute using full power, the 20 kilowatts. In terms of its cutting performance, we could cut through 10mm thick steel. Most
industrial laser systems out there require no more than 3, maybe 4 kilowatts really at the top end, and this is a 20 kilowatt laser system. There's nothing like it in the UK at all. We know this is the most powerful laser system out there.
The control that we have for this cell obviously needs to look at all the control we have inside this head. So this needs to be linked up to the robot, and it all needs to be controlled together. We have other various pieces of equipment. It's all linked into this one control, and if one particular part of the system goes down, for safety, it needs to shut the rest of the system down.
We're inside the main control cabinet of the cell now. Inside there we've got various items, the main of those being the PLC, which is really the heart of the control and monitoring of the system. We've got a Q-series PLC in there, and on there various options to control elements within the cell. Any parameters that the engineers set will all then be translated into this box. The box will then feed that information out to the relevant equipment within the cell. The whole time this is monitored, so literally every second we take a full reading of all those parameters and log that. It's all about monitoring the process, because the processes are new processes. We need to understand what's happening with a weld, so whenever processes they do, they can look back at history and see what happened at any specific time within a weld geometry or cutting geometry. We selected the GOT 1000 series HMI for the machine. It gave us a lot of flexibility in terms of graphical interface. Also, it's a piece of equipment we're very familiar with, as we've used it on other projects as well, and we know it's robust and reliable.
We've been working with this cell for approximately 4 months now, and it's been very reliable, very robust. It's not given us any issues at all.
The reliability of the equipment is very important to us, hence the choice for Mitsubishi. We have a long history with using Mitsubishi equipment, so we understand the reliability and the functionality that we get from that. So.
The interest in this cell has been very high since it's been commissioned. We've had lots and lots of member companies that are chasing work to be done on the cell.
It really is attracting a lot of work and a lot of interest from industry. Some of the things we've managed to achieve, we're putting down some welds that people haven't been able to achieve before, so we are breaking new ground. And I think some of those applications will be out there in industry before too long.